Hello, Algebra 2 students. Today we're going to look at a lesson on something called variation. So variation, and we're going to fill out a note guide along the way. So variation is the mathematics of precisely describing how one quantity, and I'll be extremely original here and say varies. Something you might also think about in terms of variation is just, one quantity changing as another quantity or variable changes. That's a pretty broad variation to begin with. Variation can apply definitely to more than two variables or two quantities at a time. I've encountered variation and we use it on a daily basis. Well, I shouldn't say a daily basis, but very often we use variation in physics and in calculus in my AP courses. I've also encountered it personally when reading about economics, about psychology. I've even encountered it in history actually before. So it's just a really precise way to describe proportionality. So sometimes instead of the word variation, you'll see the word proportional, and that may bring back memories from middle school, but it's just a way to describe some kind of mathematical relationship between variables. So I'm going to put relationship in this spot right here in the note guide. So it's just a precise language. And some people, when they hear something like one quantity is varying inversely with another, they don't really think about it precisely. And the goal of this lesson is for us to be able to develop some precise translational skills. So I think that variation is mainly composed of two basic types. So these are the ones you really want to remember. So when you hear about directly proportional variables and when you hear about inversely. So you should have already had plenty of experience with directly proportional relationships. So when I say specifically y varies directly with x, that relationship is going to be written as y equals, and then some constant times x. So it's all about multiplication when we're talking about direct variation. And that constant, which I've written as k, is called the constant of variation. So k is, whenever you see k in a formula, you kind of know that you're supposed to think about that formula proportionally, or that k is a constant. There's, of course, other constants that are very common, like a, b, and c. For instance, we were just doing linear, quadratic, logarithmic, other kinds of regressions, and the calculator was able to compute the ones that created the model of best fit. Those were also constants, and in some way could be thought of as constants of variation. But when I'm thinking about variation problems, usually it's not a regression problem or a best fit situation, it's an exact fit situation. So the other common one, like I said, is inverse variation. So if you see that y varies inversely with x, for instance, that means precisely that y equals k divided by x. So I'm going to continue to use k as my constant of variation today in all the problems. So joint variation is another important vocab word. I said it was mainly two types of variation that you need to remember. Joint is also probably the third key vocabulary word that you need to remember in this lesson. So when I say one variable varies, so when one variable varies jointly, we're saying it varies directly. So joint is kind of just another way to say direct, but in a situation where there's more than one other variable. So that's going to be joint. And then every once in a while I hear this word compound variation. Sometimes I like to use the word combined. I actually have seen both word choices in different situations. It's usually not used. Usually they'll just say one thing varies inversely and another varies directly, but that's what compound or combined variation really is. Okay, so let's get to our examples. When we're solving basic problems in this section, you kind of want to think of a three-step process. Okay, so the first one is that the current in an electrical conductor varies inversely with the resistance. So the first step is to write down the general form of the relationship. So current is the thing that's varying, so I'm going to say I equals. It's a variation problem, so I'm going to stick a constant of variation in there. And it said it varies inversely, so that's going to be division, and it varies inversely with R. Okay, so that's kind of like step one in my problem, is to nail down the general form of the relationship. The second step is going to be looking at what relationships we have, because this is just about an electrical conductor. I'm sure it's a specific one, like it could be silver, palladium, platinum, gold, copper, of course, a very common one. So we're going to apply our measurements. We don't even need to know which conductor it is. We're just going to apply these measurements to find out kind of how this specific conductor works. So I'm going to plug 1/3 in because that's a current. I don't know K, that's what I'm going to be solving for, but I know that this situation has 360 ohms of resistance trying to prevent electron flow. So now in this second step, I need to solve for K. So you do whatever you have to do on your specific problem. In this case, I'm going to multiply by 360 on both sides, so pretty simple. So I've got 1/3 of 360, or 360 divided by 3. I don't think I need my calculator for that. That's just 120. And ohms actually have, oh, and this isn't ohms. I shouldn't say that. So that's step 2. Step 2 is basically solve for K, but like I said a second ago, the best way to think about it is that you're applying a set of measurements to find a specific relationship. So what I'm going to do next is write down the form of that specific relationship. It's kind of like saying my conductor is now palladium or something like that. So K for my specific conductor is 120. Okay, so this is kind of like the specific formula that you're shooting for in most problems. And now you can do whatever they ask you to do with it. For instance, this time they said, okay, find the current when the resistance is 15 ohms. So I'm going to say, all right, I'll do that. So the current, I, is going to be 120 divided by 15. You can stick that in your calculator, but I believe you'll get 8. And these are ohms. I'm actually going to tell you just a little bit of physics today. That is the unit for ohms. You could write out ohms, but omega in Greek is the symbol for ohms. This problem actually had a little extra piece. It said to graph the relationship. So basically, this relationship is a relationship that's like 120 divided by x. So we're going to be looking at a new parent function for the first time today in my class, and that parent function is 1/x. So that's a function we've not studied before. You could put it in your graphing calculator. I'm just going to show you what it's like this time. So 1/x looks like this, where you've got one little piece going this way with an asymptote on both axes and one other piece going this way. So that is called a rectangular hyperbola, and we'll be using it as a new, very common parent function when we study fractional functions. Obviously, this is a very basic fractional function, pretty much the most basic. Okay, let's look at another example and apply our 3-step process. So the third step was basically, do whatever they want, plug in your numbers and solve for what you're asked to solve for. So same kind of thing, another example. So now suppose z varies directly with x and inversely with the square of y. So step 1, I'm going to write down what's varying and find the general relationship. There's k. It's a variation problem. I've always got k. Directly with x means we'll multiply by x. Inversely with the square of y, so inverse means division, and y squared this time. So there's my first step. I've found the general form. In step 2, I'm going to solve for k. So I'll plug in some measurements. It looks like I have those measurements over here. So z is 6. Okay, I'll plug that in. I don't know k yet. I'm trying to find it. X is 100, so I'll put 100 in for x. And y is 20, so I'll put 20 in for y and square that. And now I've just got to use algebra however I need to solve. Let's see if I need my calculator. I've got 100 here. 20 squared is 400. Hey, and that's 100 over 400. That reduces nicely. So that's really just like k divided by 4, or 1/4. So now I can multiply up that 4, and I'll get 24, and I have found my k. All right, so step 3 is kind of to assemble your specific equation and use it for whatever purposes you're asked to. So I'll say z equals, my k was 24, and the relationship was x over y squared. Okay, and they said x is 54 and y was 18. Find z. As long as you're given 2 in this problem, you can find the third. Doesn't really matter which combination you're given. So z is what I want to find. Got k was 24. X is 54, and y is 18. So I could whip out my calculator, but I thought this was a good opportunity to just show you how you could do this without a calculator, just using good mathematical number sense. So for instance, break down 24. Think about your favorite combination. I'm going to say 6 times 4. And 54, your favorite combination. Any combination will work. You could break it all the way down to primes. It's kind of up to you. I'm going to say that that is 9 times 6, right? Same thing with 18. I'm going to say that's 6 times 3 and it's squared. So I'm going to take one more step here and reduce that squared. Expand it, I should say. You could break down 6 more and 4 more and all that kind of stuff, but really, once I have this squared, I can see a lot of cancellation that's going to happen. So look at this. I'm not even going to use my calculator. That's gone. This 6 and this 6 are gone. And 3 times 3 is 9, so that's going to reduce with this 9. And you can see that on this problem, I lucked out kind of, and all that's left is 4. So there's my answer. So pretty nice. Try to flex those mental muscles. I'm not the best with arithmetic, but I know how to break down numbers, and it makes things a lot easier. All right, so it'd be good if you're watching the video right now for you to try this out on a third problem. So pause the video and give it a shot. All right, so here we go. Step 1, I'm going to express the relationship. M is varying. This time it's jointly. There's that third key vocab term. It's varying jointly, so I'll put a K in there with the cube of n. Jointly means everything is multiplied. So that's a good thing to put back up in your notes. When we wrote joint up here, it might be a good idea to stick a little personal note in here and say everything is multiplied. So that's a personal note that makes more sense to me for joint, but you can put what you like. Okay, so jointly with the cube of n, and we have to have one more thing. The common logarithm of p. So think back, what is the common log? What base is that? I think that is base 10. So we'll just write it as base 10. All right, well, we're going to apply our measurements. So it says n is 1, p is 1,000, and m is 20. So 20 is m. N was 1, and p was 1,000 inside that logarithm. Okay, reduce and solve for k. So that's 1. Log base 10 of 1,000 is 3, because 10 to the third is 1,000. And now I can solve for k, so it looks like I just need to divide this 3 to the other side. And you can see that this time my k did not work out to be an integer. I think that's fine. Okay, so step 3, I'll write down my specific equation, which is going to be k. Oh, k, what am I talking about? I just found k was 20/3. N cubed, logarithm of p, and they said n was 6, so I'll put 6 cubed. They said p was 100, so I'll put 100 right here. And I've just got to reduce this, so 20/3. And here we go. So let's see, I'm going to have 20. I know from my power tables in Algebra 2, which my class uses, that that's 216. And log base 10 of 100 is 2. So I'm going to go ahead and stick that in my calculator this time. Let me pull up my calculator. And let's see what we've got. So let's clear it out, and we'll go and put this guy in. So do we have enough room here? Let's see if we can pull this up a little bit. Okay, so 20 divided by 3, and we're going to multiply that by 216. You might want to wrap your fractions in parentheses if you're unsure. I know that my calculator actually is going to do this first and then multiply by 216 because it works strictly by order of operations. If you're not sure, don't do that. And I need to go times 2. So it looks like I got 2880. So that's the example, the answer on this one. Okay, let's look at a couple other problems. So this one says translate only. So we're not going to really be solving here, we're just going to be translating. And that's the main point of this, that you can do it in the future in any one of those classes, physics, economics, etc. So this one is actually Coulomb's law. So it says the electrical force between two particles varies jointly with the magnitudes of their charges. So I'm going to say electrical force, you know what, I'm going to call that F. It's varying, so I'll put in a constant. And it's jointly with their charges, so that's all going to be multiplied, Q1 times Q2. It also looks like it varies inversely with the square of the distance between them, and we're going to call that R, so that's going to be divided since it's inverse, and R squared on the bottom. And you can see that this guy, ladies and gentlemen, this is Coulomb's law, which is all about how particles interact if they're like an electron and a proton. And in that case, of course, they'd be pulling towards each other. This gives you the magnitude of the force of that pull, that electrical force. Let's do another one where we translate only. This time it's geometry. So we're going to write the volume of a cone as a variation expression. So if you've had geometry, you should know this formula. If you haven't, then here it is. But this time we're going to go backwards and we're going to write it down. So how do we describe that in words? So I'm going to say the volume of a cone is varying. So that varies. And how's it varying? Everything's multiplied here, so I'm going to use the word joint or jointly. And what's it varying jointly with? It's varying jointly with the radius. And where is the radius on a cone? I'm going to be a little bit specific. So I'm going to say the radius of the base. And that is squared. You could say square of or squared. And it's also varying with the height. Now, if you're like, what about the 1/3 and the pi? You know, this stuff right here. Well, I mean, that's a constant, right? A third is a number and pi is a number. Those aren't variables. So the only thing you could do is say that this varies with a constant of variation of 1/3. So, you know, k here is 1/3 pi. Those are both the constant of variation. They aren't anything else. All right, two last problems. Instead of measurements, finite numbers again, let's do something more abstract. So suppose y varies directly with x, okay. And I called these guys scale of effect problems. So pretty simple relationship. But this time we're asked what happens to y when x is tripled. So triple x, I mean, you could be thinking, well, don't be thinking about some bad movie. But let's look at, that could be x cubed or that could be 3x. Which one is it? Well, remember, x cubed is x times x times x, and 3x is x plus x plus x. So which one of those two is it? And I think that triple x is going to be like x and then another x added on and then another x added on. I mean, it's 100% added each time to get triple. So I think that this one is definitely the way we're going to go. So let's get rid of this other junk. So that's the old one. What happens to y when x is tripled? So we're going to be plugging in 3x, 4x, k is still there. And this isn't the same y, so you know what? I'm going to write it as a new one. So I'm going to say y prime. That's a way to say new in physics. It's also, of course, the derivative in calculus, if anyone's watching who's done calculus. But in physics, often that is used as notation for something that's new, a new variable. So I think that's really useful here because then we can say that the new y, and then we can search for the old y inside of it. So I see the old y as these two parts. So if I rearrange them, those two parts right there are the old y. So what I have here is y prime equals 3 times the old y, and that really answers my question. What happens to y when x is tripled? Well, what happens to it? Y is tripled as well. Or you could just say multiplied by 3. Let's do one more of these, and it'd be a good idea once again to pause the video and try this out on your own right now, if you can. So this time, suppose y varies directly with x and inversely with w. So let's write it down. Okay, directly with x again, just multiplied, inversely with w, so we'll divide that. And this time y is being doubled, or excuse me, x is being doubled, and w is being quadrupled. So the new y is going to be when we double x and quadruple w. So now again, we're going to rearrange it and search for that old y inside of it. So we need the k, we need the x, excuse me, my phone's going off, and we need the w. So let's isolate those. So we'll put the k, the x, and the w. They're all in their respective positions. I've still got a 2 and a 4 right there, and those are multiplied. So basically, I've isolated the old y, which is right here. This is all the old y, so I can drop it down. And I've got that times 1/2. And now you can clearly see the effect of doubling x and quadrupling w. it means that the new thing is going to be half of the old thing. So in other words, what happens to y? Y is halved. And you could say that different ways. You could say y is multiplied by 1/2. You could say y is divided by 2. I think halved just sounds better, so that's why I'm going to say it that way. Okay, so that pretty much wraps up this lesson. I just wanted to leave with one last note in my note guide. So one of the most common mistakes I see students in calculus and physics making, so down the road in future classes, is that when they see the word variation or something varies with something else or something is directly proportional to something else, they forget this main idea of k. In other words, they forget to include or to think about the fact that there might be some constant of variation. So in problems today, that really wasn't a big issue. You can see that k is in every single problem that we did. But down the road, it's really easy to forget that. So when you hear the word proportional or one thing varies with another, in whatever fashion that it varies or is proportional with another variable, remember that you probably need to think about, is there a constant of variation and what measurements do I need to find it? So the other idea here is that, remember, the whole concept of variation relies on knowing the nature of how two or more variables interact, not just that they do. And you are probably going to need to either obtain, or hopefully maybe the problem even gave you some specific measurements. And those specific measurements can be used to find this guy, the Holy Grail, K. So that's it. I hope you found this lesson useful, and don't forget your K down the road. I'll see you next time.